Thank you for tuning in to Bite Size Science. I'm Dr. Tristan Branthorst, and today we're going to be talking about a recent development that may tie certain types of pesticide toxicity to the lethality of the COVID-19 pandemic. We've previously reported here on Bite Size Science about the worrisome mechanism of toxicity used by the pesticide and preservative Fludioxonil. We've cautioned that this pesticide might impact our health by making us more vulnerable to subsequent stresses, like disease, for instance. Well, here we are, and please allow me to elaborate. It is an established fact that Fludioxonil, not to mention many other pesticides, cause oxidative damage to cells, with a lot of this damage occurring within the cells of the liver in particular. This is alarming in itself, but cells do have mechanisms to deal with oxidative damage. A healthy supply of a protective molecule called glutathione soaks up and neutralizes the oxidative stress from overtaxed mitochondria and other sources of free radicals. This is such a critical function that our bodies have potent fail-safe mechanisms to create more glutathione as it begins to be used up during the process of protecting us from these stresses. It is because of these fail-safes that many drugs and toxins that cause our body's oxidative damage are not categorized as true glutathione depleters. Glutathione depletion, where levels of the protective molecule drop below the quantity our bodies need to function properly and remain low, is recognized as a severe form of toxicity. This is how the painkiller Tylenol kills you when taken in an overdose, for instance. In the last decade, pharmacologists have come to recognize the danger posed by drugs that result in glutathione depletion, and these days, drugs with this side effect are illegal to prescribe, or are considered drugs of last resort. In our published work upon the mechanism of Fludioxonil toxicity, we reported that Fludioxonil creates an insidious aldehydic stress molecule, methylglyoxal, in target cells. The damage caused by methylglyoxal is harder than usual to detect, as it is indistinguishable from the effects of old age upon our bodies, and it can severely drain away a cell's pool of glutathione. After publishing our findings, we considered the worrisome possibility that Fludioxonil might act as a true glutathione depleter. Research laboratories besides our own have described unexpected toxic reactions to the supposedly safe Fludioxonil in a wide variety of non-target organisms in the environment, and there have been reports of damage to the human endocrine system, nervous system, and liver function. A glutathione depletion effect could certainly serve as the driving force behind these toxic pathologies, for which there has previously been no satisfactory explanation. In our latest experiments on this subject, we were able to detect a significant depletion of glutathione in cells treated with a concentration of Fludioxonil deemed safe by the EPA. This depletion was not only severe, but prolonged. By itself, it was not sufficient to kill affected cells, but it is certainly the case that these cells were rendered vulnerable to any and all subsequent stress conditions. This result stoked our concern that Fludioxonil might be harming our population in a way that was not only almost impossible to track, but through a mechanism for which adequate testing did not exist at the time of Fludioxonil's invention in 1993. In my proposals to NIH to further investigate this dangerous effect, I stressed the possibility that regular, daily exposure to this pesticide, which is applied liberally post-harvest to literally hundreds of different fruits and vegetables in our markets, and which cannot be easily removed prior to consumption, might combine synergistically and disastrously with other stresses. One of the stresses we implored NIH to consider was disease stress, of the sort that taxes cells at the level of glutathione creation. After all, many diseases can attack the body in such a way as to erode its cellular supply of glutathione. Similarly, viruses and other pathogens can exploit low glutathione levels as a chink in the body's antioxidant armor. We had no idea at the time that our prediction might end up being prophetic within a scant year's time. Now, we don't have direct proof that Fludioxonil depletes glutathione in our bodies, That would require a large and expensive study with human volunteers. But we do know that in the human population, from individual to individual, glutathione levels in the blood can vary up to threefold, and levels of the oxidized or spent form of glutathione can vary up to 80-fold. Science has not established why this might be, though some role for environmental toxicity has typically been theorized. This issue suddenly became decidedly relevant when biologist Alexey Polonikov from Russia published his study on glutathione levels in COVID-19 patients. It was his assertion that depletion of glutathione correlated directly with the severity of the disease. People who had low glutathione levels were likely to suffer severe symptoms and were more likely to die, while those with high, healthy levels of glutathione were likely to experience a milder set of symptoms. If the pesticide Fludioxonil was indeed depleting glutathione levels in consumers, it wasn't just responsible for making people less healthy. It could be contributing indirectly to their deaths during this awful pandemic.